Okay, well, this is a different kind of live stream. It's my birthday today, and I decided that instead of doing all the usual things I normally do, I would do something slightly different. And I've been an archiving kind of person for a long time, so I have collected about 250,000 pages of documents in my life, um, and I've kept many things. And about 15 years ago, I got those pages scanned. And from time to time, I've looked up things in them, but I haven't really done that systematic a look through them. And I thought, as a little birthday activity, I would do some looking through uh, my archives. And there's 250,000 pages, and I don't know what we're going to find. And there may be all kinds of embarrassing, horrifying stuff from when I was much younger. But I thought I would have fun doing that, and I thought I might as well share it with anybody who wants on this live stream. And so, I mean, in the sort of big picture of things, I spend most of my time thinking about the future and how to make all kinds of interesting things happen in the future. But I also believe in history, and so I pay attention to those things. This is actually just went live a new version of my scrapbook. I think there's a lot of items that should be in the scrapbook that aren't, and probably some items that are in the scrapbook that shouldn't be. And maybe today we'll find some new items. I don't know. I found this recently. This is a selfie that I took, well, a very long time ago. I'd like to figure out the age, but I think our facial feature recognizes. Let's just take a look. Let's see what it does. Let's see if I take that and I just do facial features on this. Let me see whether it gives me an estimate of how old I was. I'll probably say 24 or something. Let's see what it says. And could say something very wrong here, but let's see what it comes up with. Oh, it doesn't even find a face. That's a bad sign. Well, it is a very grainy picture because it was taken on a film camera a long time ago with my whatever it was 6-year-old estimate of what the focal length, what the focus should be, and so on. But anyway, so there's I also found recently something that sort of amused me. Oh, that's one of my early computer programs. Unfortunately, written in a paper tape code of my own design that was very cool and had error correction and all kinds of things, but where I don't have the code for the code, so to speak. But I found something. This was a school report from when I was, well, age 7 years, 9 months, I guess, 1967. And I seem to do well in poetry. I fortunately stopped writing that when I was about 9 years old and stopped being able to understand it sometime thereafter. But I was amused by the overall summary. He is full of spirit and determination. He should go far. So I think about the spirit and determination idea. I was thinking about that just yesterday when I was trying to get something to actually happen. All right. Well, let's see. Let me dive into some archives. So, how about we'll start at the beginning? Let's take a look. This is a box labeled. So I should explain. I've got all these archives are in physical boxes, and they are and these are scans of those boxes. The boxes were coarsely sorted by me probably 25 years ago, but these boxes will have all kinds of weird stuff in them. This is a box, as I said, labeled 1959 to 1972, so it's early pieces of mine. Let's take a look at what we have. I suspect that this is my stamp album. Yes, this is my stamp album. I have not collected stamps in a long time, and probably some fraction of the countries that are there won't be there anymore. Actually, this is a very strange thing. This I recognize. This is, oh boy, this is something from ancient times. This is from the mid 1960s when I was on vacation in the Mediterranean, I think in Cyprus, where it's a place where city destroyed by an earthquake in maybe 4th century BC, and literally you'd walk on the beach and there would be pots crunching under your feet from the 4th century BC or whatever. And those are a couple of things I found. It's an oil lamp that I found at that time. That was before. I'm sure in today's world, it's like you couldn't possibly pick up even something from the beach and take it with you. But world was different then. All right, let's take a look at. How about we start off with this? So I'm actually building a. Oh, look at this. This is the back of various things. Where's the front? We might ask ourselves. Hopefully that's been scanned too. I wonder why those have been scanned. Okay, that's a random fossil of mine. Okay, weird stuff here. All right, let's take a look at what I don't know. Just a quick look through the stamp album. I'm not sure. This might be in the category of. I mean, honestly, I haven't thought about collecting stamps in a very long time, but I'm sort of a little bit curious. The Portuguese overseas territories, I don't think are exactly that way anymore. It always used to be the case that the principle, and maybe it was just a British kind of thing. The that back in the day, in the 60s, when Britain still thought of itself as a sort of a definitively great power, and it had incredibly boring stamps. The word was, the more minor the country, the more exciting the stamps. I'm not sure how true that is, but anyway, let's see whether there's anything interesting to see here. Okay, that's definitely a small country with fancy stamps. Oh, that's exciting. There's a stamp in the shape, in a definite shape. Okay, well, I don't really know what. All right, so this is probably not going to be that exciting. Just more and more and more and more stamps. I wonder whether we can find something. I am going to. There's a question here on the live stream. When are we going to see an entity store of Stephen Wolfram's stamp collection? Well, that should be rather easy to get. I would say that I had hoped to have it ready by this time, but I've decided we're going to actually build a system for doing for setting up archives. I've used many archives of other people that exist out there in the world, and some of them are very nicely done. But one of the features when I go and talk to archivists and I say to them, oh, we're thinking about building this archiving system that we use all of our technology and cloud systems and machine learning and visualization and cluster analysis and all this kind of thing. They're like, oh my gosh, that would be fantastic if you did that. So we are now starting to do this, and I'm going to use my own archive as the sample collection. Someone is asking about sharing code from the NKS book. I am slowly working on that. I wish that other people could help do that. I could show some of that here today. There's the code still runs, but it's full of cruddy stuff that was specific to making code, pictures that were just so. All right, I'm going to stop. I think the stamp collection. Oh, let's look at some American stamps. Okay, the USA stamps of the time. Hard to know. Nothing that exciting here, I think. Well, at least that I can recognize. Oh, okay. So this must have been after 1968 because there's an Apollo 8 stamp. I guess that dates this. Okay. Let's see. All right, let's go back to this. Let's see what we have here. So this may be very. I'm just going to say this may be very sort of weird and embarrassing stuff. What's this? Problems and quizzes. It says by Stephen Wolfram. Okay, slightly different from my current handwriting. Do not open. It says. Okay. All right. Well, this seems to be. Let's see. So I think some probably 55 years have passed. So I think the do not open, we don't need to worry too much about. Okay, what is 9 times 12? That is a good question. Let's see, did I ever learn that one? Yeah, that one is 72, right? I slowly, over the course of my life, have learnt my multiplication tables. If you noticed in that school report of mine, it said I was really bad at my multiplication tables back in the day. I have a good memory, but I just never learnt them. And I figured that over time I would learn them, and I would try to remember when I'd learnt each one. So that was one of the most recent that I learnt, I think. The one I learnt first was 7 times 8 is 56, which I learnt when I was a kid because they used to have these kind of line up all the kids and who can answer this question. And if there's a question nobody can answer, the person who answers it goes to the front of the line. And the question that every time nobody could answer was 7 times 8. So that was the one that I learned. Well, let's see. This was in the days when I don't know. I haven't written. I said when I wrote the elementary introduction to Wolfram language that I had never written exercises before. This appears to be somewhat false because it seems that lesson one. Well, this is a lesson. An elephant has a long trunk. Okay, I'm afraid my artwork is not the most brilliant. Okay, this is one that I had picked out, I think, before to put in that scrapbook. So I must have looked at this at some time before. All right, let's go on and look at some other funky things. What is this? Oh boy, I mean, listen, this is, you got to remember, I was a lot younger then. So, oh, this must have been from a trip to Sicily. That must have been in 1966, I think, probably when I was 6 years old. Okay. Oh, 1966. Good guess. Okay. Well, at least that's a date on this. So when this goes into our archive system, this will have metadata, which is hopefully would have metadata for that particular date. I think. Oh dear, who knows? Yeah. Well, all right. Let's take a look at what else we have here. What's this? Well, what's this? Oh yeah, this is probably more a little bit later. That is from my early writing books phase. Nice cover design. The 1968 to 9 it says, but then that's crossed out. So obviously I used to use the tech of the time, which was a typewriter with a black part of the ribbon and a white and a red part of the ribbon. Okay, so this is probably some long, oh dear. Well, so this was written probably when I was 8 or 9 years old. Humph. And oh, data. Oh, look at this. Okay, March 23rd, 1950. Okay, you know what I have to do here. Let us try. Let's see here. Let's go. Let's see. Distance to Mars, March 23, 1950. Let's hope we understand that query. Yeah. Okay, March 23, it says 6550. Okay, so this says 60.56 million miles, and arguably, oh, I see. These are close approach, date of opposition, right? So that's the close approach. So that's at the minimum of that curve, and well, it's I seem to have higher precision back in the day than I do today. That's a little bit shocking. Okay, it's going all the way forward to 1971. Well, okay, at least it more or less agrees. You know, I feel like I should clip this out as a. I'm going to make a few tweets and things from this. Let me just clip this one out as something. Hold on. Let me save that in a notebook. And actually, I probably should save where it comes from because otherwise I won't know. And then I should save this. Okay, let us go. Findings, trawl findings, 01. Okay, all right. Let me let's see. I wonder whether there's anything else exciting in this in my 8 or 9 year old the Martian atmosphere. Well, I suspect that's sketch showing Mariner 4. Yeah, that was the first flyby spacecraft to Mars. I remember all that stuff. I used to follow all those things. It's a pity I sort of lost interest in space in the intervening years. It's probably good that I lost interest in space because I would have been very frustrated waiting for 50 years for people to get all excited about it again. But okay, seems like all kinds of other detailed things. Okay, let's go to the end. What happened at the end? Bibliography. Okay. Mariner 9. Okay, so Mariner 9 would be, so that must date this. Let's find out. Maybe this is a little later than I thought. So let's look at Mariner 9. And let's see whether we know when, okay. Interesting. So that claims arrival 1971. So this must be as late as 1971, I guess, unless that was taken from some distance away. No, launch date 1971. So I'm wrong. So this is from 1971. So okay, well that I was a little older. Okay, all right. The assorted box. Let's see what else there is here. What is the? Oh, what's that? That is probably from my days of designing. Well, that is weird. Okay. Oh yes, this is from my days of designing space-related things. How do I flip this? That might be a flipping button. There we go. Okay. An early UX design, otherwise known as a computer control board. I suspect this is for my little effort of designing vehicles to go on Mars, which sadly haven't been too relevant for the past 50-something years. But that's a curious thing. I wonder when that's from. I wonder what RCLP means. Receive. Who knows? Well, from a more ancient period of but I must have known something about that. Looks like a stack. Who knows? Maybe I copied this from somewhere, or maybe I made this up. Maybe this is a composite of other things I'd seen. Hard to know. All right. Well, let's see what else we can find here. This looks like some just horribly bad artwork of mine. Let's see what's there. Yes, it's horribly bad artwork. Oh my gosh. Oh dear. Terrible, terrible, terrible. The well, at least it's colorful. The well, colorful. I like the colors. I don't think my representational art is anything too exciting. All right, let's see. Well, let's move on here. Let's take a look. Should we look a little bit later, or should we look at let's look at something. Let's look at something a little bit later. How about something from? We can go back to some earlier stuff, but how about from something to do with life with cellular automata? Let's see what this is. A date, 1981. There we go. That is line printer output for those who haven't seen it. And oh wow, 1981. That looks like it's something like a game of life simulation. Interesting. Okay, maybe something different. Let's see what this is. That looks kind of boring. Okay, December 3rd, 1981. So let's see what else we have here. A blank piece of line printer. Oh, don't tell me somebody. I do believe that the back of this was scanned, not the front. That's a bit upsetting. Okay. Let's see, what's this? It says history. Okay. No, that's a different button that means, okay. Complex structures and statistical mechanics from December 1981. Systems with many components are often observed to evolve with time to a disordered equilibrium state. So this is probably one I was interested. Oh, this is amusing. Okay. However, a wide variety of complex systems do not share this tendency towards towards increasing disorder and may even spontaneously something or other to become more ordered. This is what you get for using some kind of dot matrix printer. Examples of this behavior, oh wow, I was still in British spelling in those days, are the formation of crystals or of traffic jams, the occurrence of patterns in turbulent fluids, and the persistence, I think, of biological systems. Often the results of the self-organization may be very complex, and in the case of snowflakes or living, as in the case, no, it should say as in, but it's a typo. These notes discuss some attempts to find a framework for describing self-organizing systems through which universal features of such systems may be identified. Aha. Okay, so that was then, the next page was January 15th, 1982. So this must have been the beginning of when I was working on studying things like cellular automata. Well, let's see if we can find some other evidence of that. Let's see, what's this? Well, that's a C program from 1985, much later. So these boxes are kind of muddled up. So this is C code for doing, what does this do? Well, it says copyright 1983, actually. So this is, what is this? This is number of distinct cycles. Oh, this is a cycle finder for cellular automata. Okay. Well, just for fun, we have to do the analogous thing. Let's see, I think we would just do, we would say I goes to cellular automaton of 30 of from digits. Actually, what I'd want to do is to say hash goes to, oops, I should make this a bit bigger. I always have to do these, that, and then that, I think, and then that goes over tuples of, let's say, 7, and then let's say graph of that. Let's see what that does. What did I do wrong? Oh, that's a good point. I need to say what it's tuples of. Oh, cool. So that's the state. That's what that program was trying to do. Except in those days, I certainly couldn't have made. It was just giving statistics for the components of this. But that's the okay. So it's good to know it's faster now. Let me see. What else do we have here? Let's see what this is. Future projects. Okay, well, the future has arrived, so let's see what happens, what this is about. What changes in initial states in cellular automata make a difference? Oh, rule 110. Initial density dependence of final densities in cellular pi statistics, 3D cellular automaton spin systems on the connection machine, computational universality in Ising models. That's never been done. That's still never been done. Optimal gray scales with the gray with an English spelling. That must be, oh yeah, that's an idea of making dither patterns. And look at that for something modern. Quantum CAs. Huh. Fun. Okay. Well, people talk about that now with quantum dot cellular automata and so on. Okay. Randomness, definitions, statistical, et cetera, natural occurrence. Okay, these are definitions of randomness, unpredictability, incompressibility, and so on. Okay. Fast implementation of Rule 30 pseudorandom generator. Image compression in the Apple laser writer. Okay, well, that's sort of timed out. Circularity of CA 2D patterns. 3D CA for computer graphics. Okay, well, that happened. Many people did that. All right. Let's see. I have to rotate this again. I mean, I can read it sideways, but Rule 106. I don't know much about Rule 106. I don't know anything about Rule 106. What is Rule 106 anyway? Let's take a look. Let's see what it does. What did I do wrong here? Oh, I didn't. What am I doing? I'm obviously losing it. That's what happens when you get ancient like me. That wasn't very exciting. Let's see what happens from a random initial condition. Oh, okay. Okay, I bet that does something from some non-trivial initial condition. Let's just see here. Well, we could just try. Okay, just try one thing and then we'll be out of this because I don't want to spend too much time on this. Let's do from digits n2, and then let's say this 50 there. Okay, let's do this creature. And let's do that. No, let's just do this. Let's make a table of those n up to, let's say 30. Oh, what am I doing wrong? From digits, 2-digit, I am losing it here, integer digits. There we go. Not too exciting. Doesn't look like it's going to do that much. Well, that's a little bit interesting that it has some slightly non-trivial pattern there. The fun thing about cellular automata is they're quite ageless, and you can, there's so much more to play with. If I didn't have anything else to do, I would spend all my time playing with them, I think. All right, let's take a look at what this one is. That's not my writing. That's from a mathematician called Jack Milner. Proofs of assertions about the degree of a cellular automaton map. Actually, I should keep this in my collection of things from other people. Jack is a mathematician who is responsible for many interesting mathematical things. And he was interested, I got him interested in cellular automata, and we kind of tried to work on them together. And this was in probably 1984 or so. And he was in the end very frustrated because he said, I can't really prove anything about these things, which is kind of, that's the sound of computational irreducibility. Okay. This is Jack's version of one of these things for one cellular automaton emulating another one. Okay, all right, we'll be off. Let's take a look here. Let's see what else there is here. What is that? What's this? Principles governing accuracy of approximations. Okay. Shadowing lemma. Approximate symbolic dynamics of individual orbits, blah, blah, blah. Homogeneous local systems. I see. That's sort of an ontology of iterative maps versus Boolean difference equations, maybe, ODEs, real numbers. That's actually kind of a nice picture. Maybe I should have used that for somewhere in the NKS world. Anyway, I'm going to clip that one out. I think that's kind of interesting. I've not seen that picture since. And well, let's see what else is here. Shannon-McMillan-Bryman theorem about discrete sampling. These are notes from discussions with somebody. Yeah, there'll be all kinds of stuff from other people here as well. Let's see, what's this? Another. Okay, I don't recognize that handwriting, but that's my handwriting. So who knows? Yeah, I mean, with 250,000 pages here, there's a lot to go through, but let's see, what's this? That's probably, cellular automaton fluids basic theory. Okay. That was all right, let's take a look what else. The thumb has a long way to go here. So where can we go that will look interesting? Well, what's that thing? That is a random cellular automaton rule hanging out there. What did I pick up here? A new Earth climate model. Why would I have this? When is that from? That is from 1984. Huh. Well, I have been paying attention to that stuff for a long time. But I wonder why I specifically, I bet I had this because I was thinking about kind of discrete cellular automaton-like models of global climate, something that I've not come back to because that whole field became too hot, so to speak. Interesting that I was actually paying attention to that back then. What's this? Oh, it's a paper from Phil Anderson, who I think is still alive. Let's see. Another Swolf. Let's see what this is. Monday, October 1982. Oh, this is that's printed on that's typeset with T-Rough and so on. Gosh, we have quite different questions on our live stream. I guess I should respond to this. Have I ever found a small rule 110 initial condition that never settles down? Yes, the answer to that is yes. But it depends what you mean by settle down. Let me put it this way. If I can prove that it doesn't settle down, then I know something about what it does. And you might say that what it does is to settle down, as in it starts doing something where there's a kind of mathematically understandable behavior or something. There's a question from a Tosh about Joe Armstrong's strange loop talk, or his email on collecting all functions in global function database. Well, we're trying to do some of that with our function repository. I mean, the question is not, I remember having a very nice chat with Joe Armstrong, who unfortunately is no longer alive, who was the creator of Erlang, which is something like we're using for our MQTT channel broker. It's a language for very distributed computing. Actually, I had exchanged email with Joe in the last couple of years, and he told me that I was exchanging mail with him about language design because I thought he might be interested in something. And he said, "No, I'm retired. I'm learning the violin." Unfortunately, I think retirement is probably the single most dangerous, medically dangerous human activity. And unfortunately, Joe died a little while ago. The real question is, if you want to make functions for everything, it's like, okay, but which functions are actually useful? Because you can make, I could just start enumerating cellular automata that do everything, but which functions are useful? And like in Wolfram language, we've been trying to sort of collect the most useful lumps of computational work. We've got, about 6,000 of these named functions, but now the idea in our function repository is that we have a nice organized way to collect sort of little lumps of computational work that are useful. Okay, let's go on and take a look through a few more of these. Let's see what this is. 2D CAs, it says. Okay. Two-dimensional cellular automata. Oh, that's interesting. I was using the term experimental mathematics back in those days to describe this stuff. Geometry of 2D. Oh, this is somebody else. This may be a paper that I wrote with a chap called Norman Packard. Figure 2.3. Okay, fine. So that looks like it's notes for some paper. Which, when are rules effectively solidification rules? Does rounding occur because the pointed pieces die off? Okay. Lots of stuff there. All right, let's scroll forward, see what we see here. Oh, that's interesting. Those will be simulations on the connection machine computer, which was a massively parallel computer, done in, I wonder whether there's a date here. I would guess 1986. And these are simulations, and kind of every processor was doing its own thing here. And I remember there was one time, and it'd be lovely if I happened to have this here, there was one time where doing this parallel processing, and this is representing fluid velocities, and there's one processor for each cell in the fluid. There was one time when a processor failed, and there was like this giant splat in the actual picture. So it's like parallel computing where the actual parallelism is visible. But let's see if we see that in any of these. These look very tame, if not very realistic. Perturbation difference graphs, okay. Okay, nothing too exciting there. Come on, let's see whether we get to, it's a long thumb there. Let's see whether we can scroll down and find if there is an exciting giant explosion of some processor in the connection machine. Okay, that's a plate in a fluid flow. Still, blah, blah, blah. This looks like it's, again, nah, not too exciting. These all look like quite unrealistic, hypersonic flow of a fluid, except it was supposed to be subsonic flow, although it got better. Okay, so we didn't know, no exploding processes there. So sad. All right, let's see what else we have here. I'm gonna guess what some of these things are. What is this? Some recent results and questions about cellular automata. Okay. Draft of a paper of mine. What is this? Oh boy, that looks like from the ancient past. Okay. Oh, that's fun. That's the mean field approximation to cellular automaton density. So, oh, that's interesting. That's relevant to a friend of mine named Mitchell Feigenbaum, who died recently, was a big expert in iterated maps and figured out the whole Feigenbaum constant thing about iterated maps. And this is where I guess I figured out that if you look at the average density of a cellular automaton in successive steps, it will follow an iterated map. Oh boy, that's a thing of a past era. Okay, so that is so that's the mean field theory versus the actual density of a cellular automaton in as measured by actual computation. Okay, rule 110, random behavior from simple initial conditions. Okay, that's oh, that looks like it's something about evolving cellular automata, machine environment fitness. So this is something about okay, there's a game of life thing. Scope 2 rules, base 2. Okay, this is what I used to do far too much of. This is kind of a lab notebook type thing. This is oh, that's kind of interesting actually. That is, I would imagine, I don't know what this is. This is, I think that's, this may be actually the page where I started to discover class 4 cellular automata. That's fun, because code 20, if it says a scope 2 rule, which I later changed to be a range 2 rule, and summational later became totalistic. And that first one there, code 20, is the first base class 4 rule with non-trivial behavior. Yeah, this is what these are. This must be summational scope 1 base 3. That's interesting. That's okay. So that's the early discovery of okay, scope 2 base 2 rule 20, I'm calling it here, which I now call code 20. And there's an oscillator, a trivial stripe, a long, wow, I had that name at the beginning, a death module. I used to call them when the thing, let's make one of these. Let's see, that would be a so that is something where we would go that is rule 20, code 20. I think that would go 2-2, if I'm not mistaken. Is that right? Totally wrong. When in doubt, look at the documentation. Or I could use the full form that has the actual okay, totalistic rule, nearest neighbor, N2. What am I doing wrong? Oh, K1 there. There we go. Much better. Okay, so this is that creature. Yeah, usually it dies out, and that's what I was observing on that page. But I guess if we run it a few times, those are those death modules. Let's run it a few times. Ta-da! So that's what I was observing, I guess, for the first time on this page. So that's my artist's impression of that creature there, and very symmetrical before vanishing. Okay, commonest at low density of 0.3. Okay, well, I wonder what happens if we try that. I could just try that. I could say, well, I could just say random choice. And now, of course, I have to look up the documentation for this. Random choice, weights goes to values. 0.7, 0.3, arrow 0, 1. And let's do that 1,000 times. Let's do this. Okay, oh, that's interesting. So I'm claiming that at density 0.3, that those weird behaviors, I mean, those persistent structures are more common. Well, hard to tell from just a few trials here. I'm not feeling it right now, but who knows? Okay. Okay, great. That's binary decompositions of things. All right. So this must be okay. Oh, that was when you actually had to look up papers in physical form. Journal of Theoretical Biology, volume 87, page 421, 1980, etc., etc., etc. Oh, wow. Maximum entropy formalism. Okay. Oh, so this must be okay. Well, I know what that is. That's periods of okay, so this is really a random assortment of notes. These are rule 90. Okay, that's something completely different. That's a that's a more like a mobile automaton. All right. Well, so more and more and more notes here. Let's see if there's anything notable that happens. A generating function for cellular automaton configurations, I would assume. Oh, this is computing periods from generating functions. Analogy with shift registers. All right, all kinds of things. Yeah, that was a lot of ancient times. That's whiteout. That's like the equivalent of backspacing for those who are not ancient enough to know about these things. Okay, well, this looks like just more and more and more census of what happens in these various cellular automata. Okay, let's look at some other things. What else do we find here? Master equations. Oh, that's for mean field theory. It is good that I can at least remember what these things, famous last words, I'm remembering what all these things that were written down here actually were. 2-point correlation functions. It's just lots of detailed stuff. Oh, that's rule 150. I can recognize it from anywhere. Oh, let's see whether, oh, this is interesting. Oh, this is interesting. I've been looking for a long time for the original printouts of some of these things. So that's an original printout on line printer paper of, well, it looks like rule 90 with a slightly complicated initial condition. And that's an artist's impression of rule 90. Yeah, I suspect these are these are the original printouts of various cellular automata, which probably wound up. But I wonder whether there's actual paper, line printer paper with with dates on it. All right. Okay. Anything else in this? Well, I'm sure there's lots of other stuff in the cellular automaton box. Lots and lots of notes. Lots of notes here. I think we're going backwards there. Lots of notes. Anything that looks really exciting here? Wow. Okay, that's amusing. That picture came up really recently in in connection with consensus forming with cellular automata in blockchains. It's kind of a cellular automaton that has a phase transition. And that literally came up within the last couple of months associated with this NKN blockchain, among other things. Let's see what I was doing with that previously. Draw the network. Wow, I don't think so. Okay, that's kind of funny because here, the thing that it's mentioning is it says name of hash table. And of course, the hash table is what, we're talking about hash tables when we're talking about all of these routing algorithms for these networks and so on. Okay, run all, check. Well, that would appear to be a linked list. And I don't know why I had this particular linked list hanging out here. Oh my gosh, that is disgusting and horrifying. Okay, remove successive S-break, assume successive S-break calls, return contiguous memory. That is a horrifying thing of the ancient and modern past times, so to speak. S-break is is a raw below malloc memory allocator in the Unix operating system. And I must have been, oh boy, what a bad idea. Assume successive S-break calls return contiguous memory. That's in the category of bad ideas that blow up in software engineering many years later. Okay. Shared sub-expressions. Wow. Okay, well, I guess I understood that stuff back in the early 80s, just as one does today. And that seems like a C code. That's what they say in teaching programming, right? That's what they say these days of what do they call it? Not hand coding. They call it I don't know what, they whiteboard or something. So there it is, a C struct that I wrote out for some crazy reason. I guess I was planning some piece of code here. What was I doing? Shift register. Wow, what is that stuff? What is this? And why do I have? What is a picture with diodes doing here? Well, I'm guessing this is some kind of shift register play. Okay. What is this? Oh, that's amusing. That's amusing. That's an attempt to make that was one I was thinking about. Yeah, somebody literally just sent me, oh, this is funny. Somebody literally sent me mail about this saying, I think you thought about things like this a while ago. They just sent me mail about this within the last few weeks. Wafer scale integration this is what people are now trying to do with neural nets. This is wafer scale integration of sort of massively parallel things, 10 to the 8 cells per wafer. That's amusing. Probably some prior art for somebody about how to do this. Okay, so that was a 10 micron by 10 micron cell, which is just like monumentally huge by today's standards. Updates 10 to the 7 per second, 10 megahertz. That's very unimpressive by today's standards. There's a question on the live stream about whether I think that there's a system like Cellular Automata that can do similar things to what neural nets do. I'm sure the answer is yes. I think the problem is we don't understand enough yet about the sort of shape of cellular automaton space, the geometry, the ability to have to know what a small change in cellular automaton space is like. It is kind of depressing. I don't know whether it's depressing or not, but it's like, I was thinking about sort of wafer scale integrated cellular automata back in probably 1980. I guess this is 84, 85, between 83 and 85. And it's like, finally now, 2019, this is something people talk about more seriously. Kind of shocking that these things take that long to come to fruition. All right, anything else we're going to find in this box? Oh, those are jolly. All right, let's take a last look at some of these here. And then actually, you know what I'm going to do? I am going to say open a new window. Oh, some notes from somebody else about natural language understanding. Okay. Interesting. Unclear why they're in this box. Probably shouldn't be in this box. Oh, that's interesting. Somewhere here there'll be the early stuff that I did on neural networks back in from 1981 or so. Spatially localized attractors, discrete particle models, eigenstates. Okay, so this is about things bouncing around in different. Okay. Oh. Wow. Okay, that's a blast from the past. This is back in the day. There was a work done in the 1950s by the National Security Agency on invertible block maps that wound up presumably in the S boxes of the DES encryption system, which were like, nobody understands why the S boxes are the way they are. But actually, it's one of these things that came from essentially a pretty early example of experimental mathematics, just searching through things that are very much like cellular automaton spaces. All right, what's this? Code, Swolf code. I always used to go by Swolf before I, because when I first used a computer with logins was 1976. It was a computer on the ARPANET at MIT actually, and somebody had taken SW as a login, so I had to use Swolf. Okay, so that's from 1982, and that looks like it's C code. Apparently with a bug up at the top there. I don't know why these are out of focus, but yeah, those were the days when you would debug things by writing random things on. Okay. Well, right. Okay, let's see what this is. If this is anything. PDEs, partial differential equations, and cellular automata. Linear systems with superposition, slightly nonlinear. Oh, IST must be integrable systems. That would be things like solitons. Well, that's interesting. That's an interesting claim relative to what I was just saying about deep learning. When we have so many rules, have to look at parameterized families, not random samples. Physical Hamiltonians, etc., have continuity properties resulting from their construction from simpler parts. I'm not sure if I agree with that anymore. Anyway, okay. Well, let's those seem to be some early cellular automaton images of mine. Oh gosh, this goes. And those I'm pretty sure were made on a Cray computer, and they were some kind of complicated photograph of some display to make a 3D cellular automaton evolution. It's so much easier now. I won't show what you do now, but it's just, believe me, it's so much easier. All right, well, enough for that box. Let's take a look at another box. Should we go earlier or later? Let's go to something. Let's go a little bit earlier. Let's go. Let me see what I can find. Pull this up. Let us go. Let's do something a little bit earlier than the cellular automaton things. Let's see. Let's find a particle physics box. Okay, here goes. This should be a box of particle physics stuff. Let's see. Oh, wow. Okay, that's so that is a paper that I wrote, in which we almost discovered the inflationary universe scenario. Okay, the universe would have undergone a period of non-adiabatic expansion prior to the temperature at which symmetry is broken. So I think this relegated to a footnote the whole inflationary universe scenario. Our conclusion is that the vacuum energy density of the Higgs scalar field could have had important dynamical effects in the early universe. Well, that's what people hope with it could have, for a brief period, dominated the expansion rate. But I believe that supercooling something like the universe over 10 orders of magnitude wasn't going to work. But somehow people decided later that was that it was, you got so many good things. It's an interesting story, actually. If you got so many good things out of doing that it was kind of worth the okay. This paper obviously wasn't original enough, and therefore it was actually accepted by a journal. If it had been more original, it probably wouldn't have been. Let's see. Competent review, blah, 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 blah. Blah, 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 blah. Okay. All right. Oh, that's probably the handwritten version. Oh, yeah, that's probably. Oh, yeah, that's fun. That's the that's me. Oh, well, that's cosmology. That's the number density of baryons. That's what you get for integrating the Planck distribution. And this has to do with. Oh no, this is interesting. This must be later on when I was working on why there's more matter than antimatter in the universe. This looks like it has to do with that's the Planck mass, and it has to do with the decays of particles, CP violating particles. Okay. Oh, this must be submitting that paper. Oh, and that's where we added. That's my handwriting. Added the kind of oh, that's amusing. That is amusing. Okay, leads to a brief period of non-adiabatic expansion. That's the inflation scenario, and hence a glitch in the expansion rate. However, it appears that this phenomenon would unfortunately not leave traces in the present universe. Well, that's where the inflationary universe people disagree, because they think the whole universe is a trace of that. All right, let's see what else we have here. What's this? Well, that's an exponential integral function. I recognize those puppies from okay, that's the series expansion of the exponential integral function. What is this? That looks like it's related to a renormalization group equation. That's probably the beta function of the renormalization group. Yes, those are. Oh, here we go. Okay, there's yeah, that was my. These were the days before one could type one's own papers. Okay, use of the renormalization group equations often allows higher order terms in perturbation expansions. I don't think I ever published this. This is kind of the old-fashioned version control. That's kind of a I used to just have these whole bunch of little labels, and I would just stick them on as a way of making a new version. Okay, so those are that. I think I recognize that. That is it's like the plus or minus annihilation. The virtual photon goes to plus or minus. Is that right? And that's the threshold. That's the velocity. Don't know exactly. Oh, I see. This is all about vacuum polarization. So yes, it is the same diagrams. Okay, more and more particle physics in the wild. More particle physics in the wild. Those are complicated Feynman diagrams. Let's see. Oh boy. Okay. All kinds of stuff going on here. Borel summation of k factorial g to the k. Okay. Okay, now you can guarantee that I did not make this myself. This is copied from a computer. Yeah, this isn't my kind of thing. This is Now, the question is whether the computer printout is anywhere here. Actually, on the subject of Feynman diagrams, I could probably pull up here. Let me do this. I could probably pull up. I have somewhat organized archives. Let me see what I have in my archives under people. Let's see what happens if I pull up Richard Feynman. Yeah, there we go. So this is the and I'm pretty sure. Yeah. This is interesting. Let's see what this is. I think. Yes, this is so embarrassing. These are some notes that Dick Feynman lent me one day, which I never gave back. He said he'd made them in the 1950s, so he gave them to me in the 1970s. So they had at least not been. But these are notes about how to do Feynman diagram integrals, and I really should put these out on the web. In fact, I'm planning to start exposing parts of this archive that I'm showing here on the web, hopefully in a nicely organized way. Okay, that was some random note that Dick Feynman made. Okay, so here are some integrals. Integral du over u log 1 minus u. Oh, he called it L. That's one of my favorite functions. That's the dilogarithm function. He seemed to call that L. And there's some relations about the dilogarithm function. Anyway, archives for a different time. All right, let's see what else I have in the particle physics. My particle physics bin. What's this? Looks like somebody else's draft of a paper we did. Oh, that's not exciting. Well, depends on what you're excited by, but what did this just do? Okay. What's that? That looks like it might be something interesting. Oh, look at this. Sunday, 22nd of October, no year. Ah, look at that. At open 236. Okay, who recognizes that? That is connecting on the ARPANET to a computer. That's the RAND tip. That must have been when I was at Caltech. That was the dial-up system to the internet, or was then called the ARPANET. Terminal Interface Processor, I think those were called. Okay, so this is saying this printout is from, I think, a Silent 700 Texas Instruments thermal dot matrix printer. Unfortunately, it's a pity that it doesn't tell us which year it is. That was not thinking ahead very well. Okay, so this is Open 236. Go to node 236 on the ARPANET, which was this thing called the MIT MC computer. It had an operating system called ICS, and it says 15 losers. I have to say, I think that joke must have gotten stale at some point. That's the number of people logged into the time-sharing system. And this was attach your detached tree. So I guess it hadn't garbage collected my previous session. And so now this is Maxima. See you later, Swolf, it says. Today is the first day of the rest of your lossage. How nice. It's a bit of a shame that, 1978. 1978. Huh, interesting. Okay, so this is a bit more than a year before I decided I needed to build my own version of this kind of thing. So this was okay. Was nice. The whole Maxima system. It had. I mean, it was more of a sort of. I mean, it was just a computer algebra play, but it was still a nice thing. What is this? This is. This is. Yeah. when I was 16 years old, I worked at a British government lab called the Rutherford Lab, and had the feature that you could go and, there was just some store where you could go and get random materials, and you could get these lovely notebooks that were beautiful hardbound notebooks, which I guess their main thing to say was that they're stationary office book number 616. But that was a conference that I went to about, well, it says the Kajez Summer Institute about hadron structure and lepton-hadron interactions. So I must have been 17 years old then. And list of participants, Wolfram S. There we go. Okay. Yeah. There's a character, Paul Steinhardt, who I've heard from recently, who actually went into the inflationary universe business, although quite separately from any of this. All right. Interesting. Okay. Okay, so these must have been my notes from random talks there. Quarks. And okay, well, I had better handwriting in those days. Current algebras. Oh my gosh. Current algebras. I think they've been back. I think current algebras are back, if I remember right. In conformal field theory, people are talking about these again now. They were gone for a long time. Second class currents, yeah, they're probably, I think they've been back recently too. They're things that oh wow, the renormalization group. Okay, well that has had its moments back and forth. It's always fun that these things in, for example, physics have a habit of they're gone for a while. Like they're things that I'm interested in working on in physics, which have been sort of like gone for 100 years. But when an idea is simple enough, it tends to live on. The very elaborate, complicated things tend not to survive so well. What is that? Plus and minus interactions. Okay, lots of notes about, predictions. Okay, this is predictions, always good to see. A PP bar machine at CERN in 1980 to 1982. I think it was much later than that really happened. Oh boy, that was when there was a thing called the high Y anomaly in neutrino scattering, and that was one of the discoverers of it actually talking about it, and that must have been the fact that it went up was some kind of high Y anomaly, but I think it went away subsequently after many theorists had done what you're supposed to do as a theorist, which is to explain experimental results. Then the experimental results went away. All right, all kinds of stuff there about okay, fair enough. Let's see what else we have here. More particle physics. What's that? Computer printout. List 003, job 8156. What is it? And it's just random notes about relativistic kinematics. So I don't know why it was written on that. Why is my crazy thing doing that? Not, this will be something we need to fix in the when we have our own proper archiving system. Oh, look at that, my favorite function, I told you. Polylogarithms, there we go. Oh, there he is, the polylog in the flesh. That's the dilogarithm function. And it has this very weird cuspy thing. Let's see whether we can plot a dilogarithm function. Let's see what happens. That looks like it has an imaginary part there. So I think we have to say complex plot of polylog to x. X goes from -5 to 5. How about that? What? Is that not the right thing? Why doesn't that work? Well, let's just try doing a plot of this, and it's going to fail because it's going to go complex. But I would have expected that complex plot would. Am I wrong about how this works? Oh. What I need is the thing that just plots. Oh, no. I see the problem. No, I don't see the problem. This is I need a different thing. Oh yeah, I need abs. I need a re-im plot. That's right. That's what I need. Okay. There it is today. Let's look back there. Not bad. I plotted up to slightly. Okay. Seems to agree. Except I'm showing some asymptotes here. Okay. There's relations about the dilogarithm function. Okay. Let's see what else we have here. See if there's anything else that's exciting. I'm trying to see what these just look like drafts of papers and things. Probably somewhere here is what has turned into the standard, one of the standard models for doing particle physics simulations, which I have to say was not. Oh yeah, this was my time trying to collect data on all Feynman diagrams that have been computed to that time. And I was trying to make sort of a directory of all Feynman diagrams, something I think still has not been done, which is kind of amazing. Let's take a look here. What else is here? That looks like it might be interesting. Some things that are, I don't know whether that's my writing or not. Let's take a look. Oh boy, that is a paper that never made it. That's a paper where I decided in the end that it was just based on something that just wasn't correct about CP violation in violation of time reversal invariance, but I decided it wasn't correct, so I killed it. Let's see what else there is here. Let's see if there are any more computery things. What's this one? That looks like it's more notes from my co-author for that. Oh, this might be interesting. That is, oh yeah, that's my first paper on cosmology from 77, maybe 1977. And I think this paper, which actually I should put on the web because I think it was never published because some idiot journal said, oh, everybody knows all these things about cosmology. You don't need to put the survey part in, just quote the new results. Well, of course, it turned out that it was not true, that everybody knew, all the stuff about cosmology, because back in those days, particle physics and cosmology really didn't interact very much. You know what? I should clip this out because I should put this on the web. It's perfectly perfectly respectable thing that was. Oh, this was fun. This was about if there are stable particles heavier than the proton, completely stable particles heavier than the proton, how many of them would have been produced in the early universe and where would they have showed up today? Okay. Other people have investigated the behavior of neutral stable heavy leptons, which is one of the sort of candidates for dark matter these days. Here I'll concentrate on charge stable heavy leptons and stable heavy hadrons. So the question is, okay, what happens to these things? Where do they show up if there are such particles? They're like ultra massive nuclei, okay, so we'll be bound to nuclei only through Coulomb interactions. So it's like a muonic atom, except that muonic atoms are like 200 times smaller than ordinary atoms. They don't last very long because muons have a lifetime of 2.2 microseconds. But okay, the question is, what happens? What happens if they? Well, okay, this was a very respectable paper which got shortened, and then I'm sorry to say, in the don't corrupt the young, but I sent it into a journal, and the reviewer for the journal kind of stole the results of the paper and wrote their own paper. And although the journal ended up publishing my paper anyway, and I subsequently had an interesting interaction with the reviewer slash plagiarizer of that particular paper. I think he died recently, actually. Anyway, I remember he gave a talk that I was in the audience where he showed this picture relabeled, and I was like, "How did you get that picture?" Mumble, mumble, mumble. Well, I knew this picture was not easy to compute because it involved some fancy stiff differential equations and so on. So, sort of an interesting moment. But those are the joys of academia. Oh, that's from early Feynman diagram computation. Things. Let's see, what are some of these? Those look like they're bubble chamber pictures, but what's this first? Oh, wow. That was the very first paper that I wrote, I think, when I was 14, or maybe younger. It wasn't particularly sensible. It was an attempt to explain experimental data, which at least didn't go away. All right, what are these? 1970. Those are bubble chamber pictures of particle tracks from CERN. Oh, that's a famous one. I wonder why I have that one. Oh, that's interesting. That's the omega minus. That was from the 1964, the discovery of the omega minus particle. You know what? This is something I was literally I wrote an obituary piece about Murray Gell-Mann, who was the person who predicted the existence of the omega minus, just just a few months ago. Okay, this is wow. Those are possible titles, probably, of a book that I thought about writing about particle physics. One of those projects that I never did. I guess that must have been 1978 or so, 1979 maybe. Well, now the real question is, now that I'm about to start working on physics again, whether I can get to reuse any of those titles. Anyway, okay, I think we exhausted that box. Now I don't know whether anybody's still with me, but I'm going to I'm going to go look at another box. Let me see. How about some box from when I was a kid? And then we can look at maybe some stuff about actually, you know what? Let's look at some letters from other people. Okay. And let me just look at some of those, and then I'll look at some stuff from when I was a kid, so to speak. Let's look at this. So this is probably science, history, notes, etc. So I don't know what these are going to be. Oh, a note from Georges Charpak, inventor of the spark chamber, right? And I don't think I ever met him. He died a few years ago. Oh, this must have been when I was sending out copies of the version 3 Mathematica book. Okay, that's Cy Ramo, who's one of the founders of TRW. And that's fun. Okay, this must be the TRW section because that's the W of TRW. Okay, these are just notes from people. Oh, that's Martin Gardner. Okay, Harry Wolf. That was the okay. Let's take a look at some of these others. This is from a conference I went to in 1984. Oh my, that is funny. Okay, so this is 1984, so I must have been 24 years old. So I say, this person asked me, suggestions about what to do with this piece. Perhaps I'm getting too old and stodgy, but I really think you should cut out the overt humor in the piece. One has to have a somewhat peculiar sense of humor and knowledge of personalities to appreciate it, and I'm almost certain that you will end up being embarrassed about it in the future. Okay, so that piques one's interest about what was actually there. But I do like the fact that I was saying at age 24 that I must be getting too old and stodgy. That kind of that feels good now. And let's see, let's get rid of some of these windows. Let me record the location of that one. Let me see what they were doing here. Summary session. Oh boy. What do you mean by chaotic states? Okay, so I would like to suggest that computation theory should provide other useful ways to characterize chaotic states in low-dimensional systems. In any system, the fact that in symbolic dynamics you have a sequence of symbols, blah, 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 blah. Okay. Oh, my. Oh, look at that. Leo Kadanoff, who's dead now, jumps right in with, oh, yes, it's been done before. No, Leo, it didn't. It hadn't been. Oh, well. The academic way. Okay, let's find the humor. I'm not seeing a lot of humor so far. Okay, so I wouldn't want to be too stodgy, but I think it will in the end embarrass everybody to have jokes in a serious conference proceedings. These don't seem like they're jokes. I don't know what I was talking about. Oh, what is this? Oh yeah, this conference happened to be organized by the Nobel Foundation. What is this? An important historical document while taking refuge from a rain in a woodshed at a goat farm. Einst Das Mandelbrot am Feigenbaum. Okay, well, two characters heard from recently. Unfortunately, I can't read German, so I have no idea what this says. The scroll documents early interest in chaos among inhabitants of the frozen north, particularly in the all-important fairy tree representation of real numbers. Although I was warned the premature publicizing of my discovery might jeopardize my chances of receiving any prize from the Swedish Royal Academy, I felt it would be selfish to keep the news to myself. I wonder who. Oh, this is written by Pierre Hohenberg. Okay. Oh my. I'm pretty sure that's the artwork of a friend of mine called Predrag Svetonovich. And that is That, I'm afraid, is probably an unflattering picture of Benoit Mandelbrot. That's a picture of Mitchell Feigenbaum. Oh, it is by Predrag. And this must be fairy trees, which are these kind of trees that represent decomposition of fractions. Okay, bit weird. All right, let's see what else we have here. Oh, that's interesting. That is from John McCarthy, creator of Lisp, 1984. Okay. Oh, yeah, I remember this letter. This was me sending him a short paper that I wrote about cellular automata and him telling me that it was all nonsense. Actually, I found it quite clear in some of the results curious. However, it did not relieve my previous doubts about that line of research. So this must have not been the first letter. The point of this exotic example, and others you might construct, is that cellular automata are too general to give insight into complexity unless additional assumptions are made. If you want physics, you must put in some physical assumptions. If you want biology, you must put that in. And if you want computers or intellectual life, you must design them or make a biological system and wait a very long time for them to evolve. I think that is simply not true. One might hope to learn something by studying cellular automata with small K, number of colors, and range R. However, experience with similar 1950s and 1960s studies of Turing machines with small numbers of states and symbols suggests that this hope is rather forlorn. The search for universal Turing machines with minimal state symbol product degenerated into inventing ever more complicated coding schemes to prove their universality. I believe that simulation experiments also didn't lead to much. Well, sorry there. I can show you something quite lovely here. Look at that thing. That's if you'd searched further, you would have found this puppy. The number of feedback systems leading to chaotic behavior is legion. You can point a camera at the screen or iterate copying a pattern on a Xerox machine or repeatedly copy a tape loop onto itself. In each case, you can put some device in for transforming the signal in series with the copying. Most adjustments of the system lead to degenerate fixed points, but experiment can find patterns with considerable structure. Display hack programs are in the same general class. Well, that's true, but so what? Well, anyway, that looks like my response to this. Okay, well, I think he was wrong, but so what? What is this? Ah, that is a letter from Konrad Zuse. Sometimes, well, often quoted as an early, well, he was an early computer pioneer, but he's also quoted as somebody who discovered all sorts of things about cellular automata, although I don't really think he did, because I think he was mostly interested in like finite difference, discrete grids in space and continuous numbers on them and things. But there's a letter from him. Thank you very much for sending me your books. Especially, I'm studying the book on cellular automata. It gives me good stimulations for my own studies of the field of computing space. Please find enclosed cellular computing space, the computing universe. Okay. I would appreciate very much to stay in good contact with you. Unfortunately, the distance for a visit, blah, blah, blah. I hope there will be an opportunity for a meeting at any time, at some time, I think he probably means. But unfortunately, I think he died soon after this. But his computer, supposedly built during the war, was an electromechanical binary computer. And I was on the hunt for a while because that computer, the actual physical thing, was in a house that was bombed in World War II. And there is pretty good evidence that it's sitting in a kind of collapsed basement or something in Berlin, and it's would be an interesting piece of urban archaeology to go dig it out. Okay, let's see what else I have here. See what other exciting things I might have. What's that one? Oliver Sacks. It's a nice weird. What is that sea anemone thingy? Okay. Oh, that's John Wheeler, inventor of the word name black hole, writing me after I sent him NKS. What does he say here? Let's see. My poor memory fails to come up with the name of that great modern philosopher of science who tells us that a new outlook or theory establishes itself by making some astonishing prediction. So he says, but naturally I'm eager to know what the idea is that is essential to the whole work and the apparent preposterous position in which it exposes itself to destruction or victory. He wants to know which page in NKS is okay. I wonder whether I responded to this. I certainly went to see him. May have been a few years after this, because sadly I was very old. He was 95, I think, at National Physical Laboratory. So ACE was a automatic computing engine, the first computer, and this was first computer in England. And we're going to have a slower, purely something or other, small 4 suitcases with 10,000 number magnetic drums store any at all only. Okay, so I get the machine to work out the disjunctive normal form of something. Okay, all right, cool. All right, let's see what else I have here. So are there any other interesting things? That's another one from the Turing archive. Let's see what else there is here. I wonder what that is. That was when I went to Illinois to start my Center for Complex Systems Research, I would assume. That's a note from Martin Gardner from 1984. Well, that's nice. Let's see what any of these are. Let's see what this one is. Paul Halmos. Oh my gosh, this horrifying thing. Oh, I'm not sure I even found this. Oh my gosh, this was this piece of absolute silliness. This was Benoit Mandelbrot sending in something claiming that he had done something that I'd done before I did it, but it wasn't in fact true, as I discovered many years later when I met the research assistant. Yeah. Okay, that was me saying it looks kind of silly. Okay, all right, that's probably not its finest hour. That was when Benoit died. I was going to write an obituary piece, and I started pulling out letters like this, and I'm like, these things are so horrifying. I can't write something because I'm going to end up writing about all these really horrifying things. And I ended up when his posthumous autobiography came out, I ended up being able to write a review of that. That was much easier. Yeah, it's funny how those kinds of things work. Let me see, what else do we have here that looks like it might be interesting? What on earth is that? Extremely messy set of notes. Oh, just some random notes with probably about diffusion limited aggregation with one of the inventors of that. Okay, well, let's see. Are we up for let's look at some stuff. I think I'm signed up to talk about the future in an hour or so, but let me go on poking around at some of these things, and let me know if people find it interesting. Let's see. Should we look at early Mathematica, or let's look at early Mathematica? That seems like it might be fun. And then we'll look at some stuff of mine from like super early in life. Okay. This may be all early Mathematica. Notes, let's see. It's about memory allocation. That's not the most exciting thing. No, that's the invention of / dot. That was that was when functions were still with dollar signs instead of the ampersand postfix. That ended up being functions. Okay, so those forms are still the same. Try to compile definitions of pure functions. Oh gosh. You know, this is where things get really freaky because, we've got a big effort now to do compilation. And I was already talking about that at that time. Well, AP became apply. Despite the pun of map, multiple apply, and app for just apply. But I think it was probably happier for being all spelled out. All right, let's see what kinds of things we have here. Looks like there's some source code here. Let's see. 1986, November 1986, Swolf at Panther. Panther was the name. It's been funny over the years, all these different namings for machines that I've had. I think the very first set of named workstations were named after stars. Then I had big cats. Then when we started Wolfram Research, all the early machines were named after types of bugs. Okay, well, this looks like it's a to-do list from '86. Okay. Algorithms needed for Omega. Omega was the name for what became Mathematica. And yes, a wag would say one's gone not from alpha to omega, but from omega to alpha. Signature permutation, matrix eigenvalues. Okay, pure functions. There I'm proposing percent. Symbol table entries. What does that mean? $A. Special variables, underscore integer, underscore special. Well, that's not what happened. So this was really, really early. This was like only a month or two after starting the project. Dispatch tables. The heck does that have to do with anything? Evaluator schematic. Wow. Wow, that's interesting. Okay. Well, that's kind of interesting. Maybe we should publish that now when people ask how does the evaluator work. Well, there's an answer. Well, at least there was an answer in November of 1986. Various functions, quotient of n1, n2. We only and divides q. We only added divides q very recently. Integral table. Oh wow, I had already the at concept then. Internals, okay. Iteration. There are many relations between iteration type constructs. Map, apply, flatten, distribute, power distribute. I don't think that ever made it. Iterate, which turns into table sum product do. Sequence, which became table. That became table. Oh, the pattern matcher. Description of the pattern matcher. The omega pattern matcher. Notes about pattern matching. Oh, that was when we thought about having hold as a quote sign. Part extraction. That was when we thought about having at as the part extractor. Oh yeah, there was a time when we thought about having macros, where string colon colon equals new string defines string transformations made before the parser. That was such a flaming disaster in SMP, my previous system before Mathematica, that I didn't repeat it. I mean, what happened was I remember the classic was somebody redefines capital U to mean the union operator, thinking that that's very beautiful and clever, and you can type A capital U B to mean A union B, and it's the but then somebody was typing in a piece of code and it happened to have a capital U in it, and so the macro preprocessor rewrote that as a union and blew the whole thing up. So I haven't done macro stuff since then. It always takes a long time to go back to these things that oh, that's interesting. A generalized iterator. We still don't have that. We still could have that. Iterate, F, expr, etc. Oh, so we did have table at this point. Is just iterative list. Maybe we should have this construct. Okay, we should put that on the next. Somebody from my team is paying attention to this. In our ILD meeting, we should discuss this. This is only from 1986. We're only, whatever it is, a third of a century later. Still not such a bad idea. Oh, I guess we called plus add back in those days. And accumulate is what became fold. That's kind of fun. Printing action. Okay, graphics, either ASCII, Unix DVI codes, bitmaps, or the very modern PostScript. Modes, omega input fast read only, blah, 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 blah. What does unflatten do? Oh, unflatten does, I see. Unflatten, that's an ugly and silly operation. Unflatten almost does partition, but not quite. I wonder what other functions there are here. Functions are like little nuggets. You have to pick them up wherever you can. And this is so this is about load. That's what became get. Top level interface. In, out, input lines, output lines. Oh, in is the list of input lines. User interface. Well, these things here, these are like keyboard shortcuts because this was all command line interface. Oh, wow, that's interesting. Records the start and finish times. Omega.history would be a file that records the start and end times, start and finish times. I guess I was not properly Americanized even then. Of sessions, UIDs, logins. Okay. Files for Omega functions. Oh my. Boy, this is a thing we're about to do again, which is to have file bundles for notebooks where there's, look at this. This is the thing, the .om file, very very Buddhist or something, and description.doc. Well, that will have been before there were .doc files that were Word files. Yeah, this was probably during the time. Was it still during the time of WordPerfect? I think it must have been. There may be a header. Okay, the text files should usually be bundled. Oh, wow. So this is like a zip file, but there weren't zip files back in those days. Okay. Oh my gosh. It drives me crazy looking at all this stuff. So this is 33 years ago, right? There's a function called spread here. Okay, who knows what that is now? That's the function called around that just got introduced. We just finally managed to make that really, really work. Okay, this is the idea of having a number that is actually a modular number. Not an obviously stupid idea. P-adic numbers, I don't think the demand for those has been all that high. Yeah, should trace of expr should cause printout whenever expr appears. Oh, that's interesting. That's an interesting idea. That's an interesting idea. To have something where you can essentially post a thing that says, wow, we could do that with hashing and things nowadays. That is a good idea. I mean, the trace function became something very different. Okay, that's another thing for our ILD meetings. But that's a really interesting idea to have something where you just say, if ever my program produces 37, I want to know about it. So if ever the evaluator sees a 37, I want to know about it. Good idea. Wow. Generate. And actually, this idea about a wrapper for modular numbers is also something that probably should be considered. This is one of the strange features of a life like mine, is that, you do these things and it's like, there's things where it's like, you almost get there, like, and then 30 years later, you finally do it. Utilities. That doesn't look very exciting. Well, that was interesting. That's the so that's very early days of very early design documents. That's an interesting document. Actually, I should store where that is, because that's one I probably want to pull out. So let's see what some of these others are. That was fun. That one. Initialization and file system interaction. Oh gosh, we're still working on this stuff. It's unbelievable. Still, it's the same thing all the time. Yeah, what initializes the initializer is always the problem of initialization. It's like, who gives permission to the permissions giver? More notes. Is that the same thing? That was the same. That was a piece of the same document. Let me see here. Let's try taking one of these random ones. That looks like it's a boring piece of C code. Apparently with something, I don't know what that is, some weird stain on it. What is this? That looks like it's a very early, we can do PostScript. Oh, there we go. PostScript. It's depressingly similar to what we would get today. Okay. This file printed from a Mac 2 to a QMS ColorScript 100 printer in 4 minutes. That's kind of something. Okay. I can take a quick look at this. Transparencies. The first Mathematica short course. Roman Mader is still with the company. Teo is still involved. Jerry Kuiper unfortunately died in a bicycle accident many, many years ago. The Sun beta version was 1.5 weeks away. So this must have been, product release, June 15th, plus or minus 2 days. Okay, it wasn't too bad. We were, let's see, how far out were we? It was actually June 23rd. So for release date predictions, that is not too bad. Okay, well, the kernel front end system. Notebooks. So depressing. I mean, this was from like 33 years ago. Documenting your calculations, creating quotes, live textbooks. We're still not fully there. People have been doing these things a bit, but we're finally now, with cloud notebooks and all that kind of thing, we're packages for specific areas. Well, and that was what became the Calculus and Mathematica project there. types of application packages. Okay, well, we have most of these. Generalized type geometric functions, I think we have that. Laplace transforms, we have it. WKB approximations, we added it in the most recent version. Dirac gamma matrices, I know we have that in the function repository. Continued fractions, we have that. Lie groups, we still don't have. Tables of physical constants, we absolutely have that. Homotopy groups, we have that in Wolfram Alpha. We don't have that in Wolfram language. External interfacing, a TROF generator. TROF was a Unix typesetting language back in the day. Controller robot, okay. Part of system software on various machines. CD-ROM libraries. Just what we need is a CD-ROM library. Yeah, nobody expected the communications channels to get as fast. Well, I certainly didn't. Back in those days, it was only soon after people had told me, you'd never be able to transmit data faster than 1200 baud, 1200 bits per second on a copper wire, like a phone line. And turns out they were wrong. Okay, well, this is fairly late stage stuff here. Coming very soon. Okay. External interface. The okay. Well, all right. Let's see, is there anything else that looks exciting here? I wonder what. I mean, there are probably a lot of notes from. Oh, there's a to-do lists. Let's see if we've done them all. Tech tables. I don't know if we've done that one yet. Axes on contour plots. Yeah, these we've definitely done. Tick mark lengths. Well, this is project management systems before there were project management systems. Let me see, what are all these? (1987). Oh, this is me complaining about the typesetting of the version 1 Mathematica book. Let's see what else is here. That's probably version 1 introductory stuff. Oh, that's from SMP. That's from the predecessor of Mathematica, my SMP system. That was an annotation of which special functions we were going to get. And we never got the hyperbolic sine integral function, apparently. Or the Catalan beta function. I wonder whether we have those now. Something for the function repository, if not for anything else. Another thing to look at. There is something a bit strange about going through one's 33-year-old notes and saying, oh, that's something we should put on the meeting agenda for next time. But what is this? Oh boy, that's deals. Yeah, that's when we were making deals about first version of Mathematica. Those were various people. I recognize some of those names. Some of those people went on to become significant fishes in a variety of companies. All right, let's see, there's something handwritten here. Let's see what this is. Mathematica user registration. Oh, wow. Well, that's me. Oh, wow. This is more deal stuff. Ardent, which became, that was the place where a chap, Cleve Moller, who had sort of worked on MATLAB back in the day, was at that point working at Ardent before he decided that MATLAB could be commercially viable. I think, and these were companies, Multiflow, Sequent. These were companies that are no longer. Oh, that one was in Connecticut. See, I know my area codes from the fact that I'm an old fogey. and that one I'm pretty sure is Oregon. Am I right? Let's see, what else do we have here? Anything else that's fun? What's this? Software license agreement with a vendor. Oh my. These are probably, yeah, we're getting down to license agreements and deals. Who's that? Oh, that's a distinguished signature there. That's Steve Jobs' signature from the deal we made with Next. Very stylish signature. The lowercase. Let's see what other strange things there are here. That looks like it's an early package. That might actually have package annotation data. No, this is vector analysis, which we finally added. Finally, as a system thing, maybe 4 or 5 years ago. It's kind of messy the way that has to work. Let's see. What else do we have here? Scroll. Did this back scroll? I think it did. Well, there's some floppies. What's this? Let's see what that is. Modifications to list manipulation functions from February 1988. This was a fax. Why is that? February 1989 from Pacific something or other. Oh my gosh, I don't believe this. We just added take while in the most recent version. That is so frigging shocking. I'm going to clip that out because I want to remind myself about how horrifying that is. I mean, this is from 1988, for goodness sake. And we finally added that. Okay, return self. Yeah, this is one that we still haven't done. Okay, that's another one for the agenda. No, we changed the syntax of compress, graphics, scaled, circle, edge form, Bezier curve. We finally added that a few years ago. Ticks, tickery. Yeah, the horrors of tick specifications. Yeah, this is a kind of a fun document. Dispatch tables. Yeah, we have those, although those are increasingly hidden from public view because they happen automatically. And I'm now just inclined to just take a look at what this is, and then we'll go to a different box. Okay. Oh, those are the days before GPS. Those are directions for how to drive to something. Oh yeah, that was yeah, was back figuring out when we were publishing the Mathematica book with Addison Wesley Publishing Company, long time ago. All right, let's look at something else. And I'll take requests to look at different types of things, but let me see. I'm gonna take a look at some stuff from when I was in elementary school. How about that? Since I'm feeling old today. That was a while ago. Let's see how many horrifying things we can find there. Let's see. Where would it be? Here we go. Oh, let's see what there is here. Let me just preface this by saying this may be very horrifying, and I was probably like 8 years old. It's the okay. If I open this, don't be too horrified because I don't know what it is. Oh my gosh, my gosh, my gosh. I do know what this is. This is too horrifying. This is truly too horrifying. This is a speech that I gave when I was 12 that I actually found recently for other reasons. And it turns out to be a speech about basically AI ethics, which is just so outrageous because it's it's terrible, terrible, terrible. It's terrible. I don't know whether I have the nerve to put this out on the web. I don't agree with all views that I had when I was 12 about AI ethics. However, it is kind of shocking that I'm going around talking about AI ethics today when I was giving a speech about AI ethics when I was 12 years old. Let's see. This is just, oh no. This is way too horrifying. This is way too horrifying. Okay. No, we're not going there. Let's see. Let's hope this is less horrifying. Oh, wow. That is something I wrote for the Latin Prose Prize of 1972. Well, let's see. Tempore, that's time. Quad putabat, that must be the imperfect tense of like think, the word for think. Wow, this is fancy Latin, at least by my standards now. Quad Well, somebody can probably translate this. I can only do some little pieces of this. Maybe that means I got top place. Who knows? I am. Let's see. What is this? This looks horrifying. Let's see how horrifying this is. This must be from when I was 12. This is presumably geography. Oh no. How horrifying can it get? Let's see. Okay. My little Well, I was making a big effort with my handwriting there. I definitely was into the nice diagrams. Boy, my writing there looks pretty good. Okay, that's a bit unfortunate. That's definitely the computer wannabe. I had never used a computer by this point. I had seen a computer, but I'd never used one. But that's definitely the computer wannabe font there. Humph. Well, I can't even imagine what the British version of what the one learnt about the Middle East was in those days. Oh, that's fun. A bar chart. I've even visited both of those places now in Australia. Okay. And that looks like an early self-important underlined signature from the 12-year-old me. I wonder what map projection that is. Somebody's teacher, somebody saying, ugh, I wonder what that means. Why? Maybe that's some comment on the geopolitics rather than on the diagram. Having found the oil, the next job is to get it to the surface. This is done by using a drilling rig, etc., etc., etc. Oh, wow. Great Britain. Okay. This is kind of funny. Near Europe, this means we are in touch with other nations easily. Center of free trade area. This makes trade easier. Well, of course, that's been back and forth since those days. That was 1972, just after joined the common market, I think. Britain's exports. Wow. Nowadays, it's probably half finance or something. Gramophones, intercoms, TVs, fridges, spelled very peculiarly. Okay, for some reason now we go on to Roman London for some reason. Okay, well, power. Teacher saying, a good idea, pretty well executed. 25 out of 30. Okay. For my Power for London infographic. I don't know how common these things were back in those days. I really have no idea. Coal mining in England, not there anymore. How coal mines work. Okay, lots more stuff. Let's see whether there's anything interesting or horrifying here. See, this is what you get by keeping all the stuff. I'm a glacier flowing. All right, what is this about? Glaciation. There's probably things I could still learn from this that I don't. Oh, okay, that's kind of cool. Okay, well, so much for that. All right, that was that. Let's see what else there is here. What is this? This is probably, okay, this could be horrifying. Oh, this is class ranks. That's odd. I seem to do well in math there. That's a surprise. I always did well in English. Oh dear, this is probably horrifying, horrifying stuff. Okay, this is me trying to write ancient Greek with apparently mixed success. Getting 21 points out of 30 apparently for my efforts. And let's see what else we have here. I think that, oh boy, a project about the United Nations. Okay. More and more and more random things here. What are these? Paper. Why is that called paper? Oh boy, Latin. Weird Latin exercises. Oh, this is translate into Latin. There are those who think that men ought not to try to fly. Sunt autem illae qui veros lunam volare. Okay, well, that was a useful thing to learn. It really is a useful thing to learn, given that given that I've been involved in naming things with Latinized names and things. It's sort of useful, I suppose, that I learned how to translate from English into Latin back in the day. Let's see, what is this about? New architecture, which wouldn't be so new anymore. Perhaps in some respects, the building materials of today are better than those of yesterday. Concrete can be made in any shape. It can be as large or small as you like. And above all, it is strong. I think that imitations of old houses are very, very much worse than genuine new ones. Oh, I see. But a building must look nice and be efficiently designed. For example, the new St. Anne's residence block, okay, which is some building in Oxford, which is where I grew up and went to school, is made very much prettier by the introduction of wood inside some of the windows. However, the engineering block is an all concrete construction with nothing to break the grey monotony. That building is really, truly, unbelievably ugly and looks even uglier now. Oh, that's funny. If a building or complex is not designed in one go, the resulting nice blocks in themselves pretty become disorder pretty, I'm afraid is it probably reads better with a true British accent and things, become disorderly and not pleasing to the eye. Possibly a good example of this is the engineering block where buildings are topsy-turvy all over the place. The curves which modern concrete can be molded into seemingly lacking in both buildings, but in the engineering block, there's some signs of concrete's vast strength. Okay. Wow. Okay. To live in caves of dull grey concrete would seem unattractive to anyone at the best of times, but if that concrete is also inconvenient and inefficient, then it is even worse. Okay, well, that was the 12-year-old me with an architecture criticism or not. Um, what is this? There are three elements in which our environment is threatened: air, land, and sea. Wow. Okay. Environmentalism in 1972. Interesting. I wonder what I had to say about that. We'll attempt to take these topics in turn, and I will start with air. Many people will have read in many books that in a hundredth of a second, Saturn V rocket, I guess, will produce more carbon mon and dioxide than a man in his whole life. Cars seem to be, wow, I didn't know people thought about this stuff back then. Cars seem to be, along with industry, the major polluters of our atmosphere. As many people may also quote out of books, if the CO2 content of our atmosphere rises beyond a certain percentage, the surface temperature of the Earth, oh, look at this, I say will rise by 20 degrees centigrade, and the teacher who is correcting this say could rise by 20 degrees centigrade, thus melting the polar caps and submerging all land below the 200-foot mark. I don't think anybody believes now that that's possible. Now, how can this be prevented? Industries have been forced to install filters in their chimneys, but this does very little good, really. If a method could be found of producing intense heat with the use of hydrocarbonic fuels, then this menace would sound better as with a 12-year-old British would be gone. Lasers seem to hold a possibility, but the electricity to power them would have to be produced. And the only way to do that without combustion, HEP apparently stands for hydroelectric power, is atomacy or something. It is possible to power cars by electricity or by fuel cells, thus reducing this hazard. Okay, what is that's presumably atomic power, or atomically or something. Second topic I would deal with is land. There are only really two divisions of this: organic and inorganic. To start with inorganic, dumps, old tins, cans in American, and plastic constitute the major part of this hazard. Plastic is the worst of these offenders. Once anything plastic has been deposited anywhere, it stays. New decayable plastics are being looked into. I think they exist now, but these will not come on the market for many years. In this day and age, there is a craving for disposableness. Everything has to be disposable, but when it has been disposed of, where does it go? The answer is in the environment. In our lives, we each produce 40 tons of waste, and at the moment, 30 of these tons are going out into the environment and polluting it. Okay, I must have been quite a believer in this stuff back then. So how can these be prevented? Already there are heavy penalties for dumping by individuals, but not for dumping by the state. So science now has to be led us into this mess, must get us out of it. The other sort of land pollution is that of animals. Many interesting species are getting wiped out, despite the repeated efforts of the conservationists. Perhaps at this rate, Homo sapiens will be the next species to disappear, misspelled. Sea pollution is perhaps the most publicized of them all. Everybody knows the story of the DDT being washed into rivers and stifling the plants and animals. So does everyone know about the waste being pumped into rivers? So the initial problem is, how do you get rid of waste? The ultimate answer is, oh, this is amusing, is to dump it in the sun or into a star. But since this is at present impossible, more practical methods must be thought of. That's a pretty good idea. For one of the favorites here is dig a big hole and chuck it, American, throw it in. But that only lasts so long, and then we're back with the problem. What I think, what I think is perhaps the best way to dispose of waste is to make land in the sea with it, i.e., to make a landfill. Okay. Well, more notes here. That looks like a battle, some battle of Moscow or something. Okay, all sorts of. Oh, that's amusing. That looks like a phyllotaxis pattern. I wonder why I was drawing that. Weird Venn diagrams. Wait a minute. Greek prep. Cute. Oh, there's S. Wolfram, except I didn't at that time know about the digamma, which would have been a much better W. I can't even imagine what this is. Oh dear. This is about the history of Ireland. That's too horrifying. There might be somebody from Ireland on this live stream. Probably shouldn't read this. It's probably got something very, very horrifying in it. It is often necessary in the study of history to know the geographical location of a place and also the reasons for certain movements of people and animals. The geographer also may find it very useful, if not essential, to also be an authority, at least on the history of the area that he is studying. It may not become necessary to have very much beyond a superficial knowledge of the topography. Blah 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 blah. Okay, I wonder why that is. Who knows? Somebody's asking how my view of climate change has evolved since I was 12 years old. I'll leave the version from when I was 12 years old. I think I'd be too controversial in today's world. Let's see, what is this? Oh, this is my school magazine from 1969. I can probably look up my let's see, where would I have been there? I would have been, let's try there. I would guess, well, we can look. Let's see how I did in various subjects in 1969. Let's probably have to go right down to the end. Long school magazine. Okay, where was I in those days? Where was I? Yes, that looks like my. Yeah, there we go. So let's see how I did. So this will have been when I was about 9. Well, actually, probably says the ages. Here we go. I was 9 years and 6 months old, and they rank these in old world form. They rank these people in order of how they did in Latin. So go figure. So let's see. So I didn't do that well in Latin, it seems. Many did better than me. Some have even continued. That chap is quite a well-known writer these days of, I think, of historical fiction. So maybe he's gotten to use his Latin. That chap always had a hobby of studying fungi when he was a kid, and he became a biotechnologist, but still does fungi. And I bet he gets to use his Latin there too. All right, let's see. How did I do? In English, I came equal 4th. That was a very low showing. History 5th, geography 1st. Okay, maths 9th. That was actually good for those years. And French 2nd. I don't think I continued my prowess in French. Sadly, although I can more or less understand it. All right, well, lots of other school magazines, it seems. Let's see if there's anything else here of note. What's that? That's probably from a little bit earlier. Oh dear. That seems to be a notebook from some kind of let me see. Oh wow, a bunch of broken GIFs there because this thing didn't reload the cache properly. Well, whatever. Okay, enough of that box. Somebody's noting the someone's asking, what scanning filing systems do you use to keep an organized repository of documents? It's really crummy right now. We're I'm going to mostly ultimately I use cardboard boxes. These scans were done over a several-year period, were surprisingly hard to do, and there really isn't a magic bullet for doing these scans. They're just hard. And I think the what is this? The it's we are now that I'm going to try and expose some of this archive. We are working on a nice, clean, streamlined system for doing all this stuff. Hopefully, we'll be ready fairly soon. The question: if I were able to send myself one of the documents I've seen today, what would it be and why? I would send myself Wolfram language description, because that's the most, knowing that back, that's kind of a representation. It's a distilled representation of what I and others have figured out over the course of many years. And if I'd known that, I think I would have understood it back when I was 12 and so on, and it could have saved about 35 years or something. So yeah, that's what I would send. I definitely wouldn't send my notes on dandelion clocks and things. All right, we can look at another. Let's take a look. What could we do here? We could look at. Let's look at something. Maybe we can look at. I mean, I've got all kinds of weird stuff here. It's let's look at something here. Let's look at. Hold on. I think we could look at. Let's try box 253. I have a note that might have something in it. Let's see. Box 253. Why would that have anything in it? That looks totally weird and boring. That is called Travel Info Receipts and Postcards. That looks potentially absolutely deadly. I don't know what this is. What is this? Oh, wow. Huh. June. That was the last time I ever did an exam, except for going to get driving licenses every so often, where the person doesn't believe I haven't cheated because I got all the questions right. That was, interesting. Okay. That was the first year exams in physics in Oxford, and then I exited that picture. So I think I even got the top grade in this exam. What a thrill! Back in the day. And this is, oh wow, I can see that from without. That's kind of funny if embarrassing. This is school prizes from 1973. Those are like book prizes, and those are like book plates for put these in the books you buy with this prize. Sadly, they obviously didn't make it to books. All right, what are these? Oh, that's the June 1977. That's the exam paper. Wow, you mean I could actually do these things without a computer? That seems very implausible. I think I probably just thought about it the way, well, I guess I hadn't made a computer do algebra, but had I by then? Yes, I had. I had used a computer to do algebra by then. I absolutely had. So this must have been like super painful, actually. Yeah, well, good that we can do those instantly now. The let me see, what can I find here? What's that? That looks like the results of my what are called O-levels. Oh yeah, that's cool. Those are the grades for out of 1 through 9 for the standardized exams. They're kind of like the what are they analogous to in the US system? I don't really know, but I think O levels still exist. But anyway, I was proud of that. I got a top grade in all these subjects except for English, and I already knew that it was well known that anybody who was actually a good writer was going to do badly in these English things, and I was actually a little disappointed I didn't do worse than that. Um, that was I think after I after my realization that doing well in exams and things wasn't that exciting, and I was going to, but other people who would sort of compete in them were much more excited than I was about doing well. So I should just do the minimum amount of work and let them have their excitement. So that was what is that? Oh, that's amusing. That is an air bill from when I shipped all my stuff to the US. When was that? That must have been, that sounds about right, 7th of May, 1978. That was when you could just take a bunch of boxes to an air freight place, and this probably says how much gross weight. So it says 502 pounds. That's a bunch of books. I'm sure I still have those books. I assume that's in pounds. 502 pounds, maybe? I don't know. 522. What is that? Number of packages 16, weight 522. What is the 522 pounds? That's a lot of junk. That's a lot of stuff. Anyway, okay. All right. Something different. This seems to be very assorted stuff. That looks like a speech that I gave, a company speech I gave. I don't know why this box was thought to be particularly interesting. What is that? Welcome you to membership of the American Physical Society in 1977. A card-carrying physicist since 1977. There, that's a good claim. What is this? Oh, that was a paper I published a long time ago. What is that? Oh, that's amusing. That's from visiting the US in probably 1976. I'm afraid that's a thing that can't exist anymore. That's a little tourist brochure from the World Trade Center. All right, what are these? Huh. Okay. I never remembered that I did anything like that. Okay. Let's see what any of these are. Doesn't look very exciting. I don't know why these are thought to be interesting. I mean, this looks like it's just, those are just, oh, they used to be preprint. These are so-called preprint request cards. That was before you could go to Archive and just just look up any preprint you wanted. You had to like send a physical card to get a preprint. It was always fun for me because when I started writing papers when I was in high school, I would get, and I was at a boarding school at Eton, and I would get I would get all these cards addressed to Professor Stephen Wolfram, and there I was as a 15-year-old. It was kind of fun. Oh well, that's safe to show because that account doesn't exist anymore. And that was while I still kept track of those things. I'm so bad about this now. All right, let's see if I can find. I have an idea for another thing to find here. Let me just show something else here that might be fun. Let me find something. Let me see. Let's see. I've got just so much stuff that is, well, as you can see, I've got a lot of random weird stuff. General correspondence. I wonder whether that would have interesting things in it. I've got the project I tried to do to make a C interpreter back in long time ago. That's never saw the light of day. What I was looking for was, let's see. Oh, this might be interesting. This is yeah, this one is interesting. This is from SMP, predecessor of Mathematica and Wolfram language. This is so this is I started this in 1979, and this is these are design documents, and so that was, yeah, I mean that's an example of a bad design idea, which was the that somehow pattern variables that I had the idea of pattern matching for function definition, but I had the idea that pattern variables would be annotated, which was a bad idea, and that the unannotated version would be used for the one would always annotate them. So we didn't have the idea of blanks. So this makes a rather ugly thing here for this if. And also in SMP, because people at that time, people couldn't type, and there wasn't anything like auto-completion, and so you had to keep variable, things short to let people be able to type them. So this is like new was going to be, eventually became n for numerical value. Let's see what there is here. Special operators. Okay. Property set. There's some not very good ideas there. Okay, let's see what else there is. In terms of that was implementation stuff. So this was probably a very, very, very early design document. So this was probably within a few weeks of starting the design. All right, let's see what else there is in this one. There's probably a lot of stuff here. What's that? Oh, that's weird. That's when I was at Caltech working on SMP, the PH department looking for computrolls. Probably will be called hackers these days. Complete with an ad for pointing out that they attract moths and insects. Okay, that's interesting. Okay, this is early SMP documentation. Let's see, what's this? Tentative design for a new symbolic manipulation program. It was originally going to be algebraic manipulation language, and it got changed to program. Okay, existing languages, blah, blah, blah. Oh, that's some camel that I think turned into OCaml, I believe. Unless it didn't, unless OCaml comes from ML. Not sure. This is always a fun thing to point out, that there were these three programs that were made by physicists in the early 1960s to do algebra: reduce, scorn skip, and Ashmedai. Reduce was written in Lisp, very fancy. Ashmedai was written in Fortran, and Skunship was written in CDC 6000 assembly language. And you can ask the question, which of those physicists went on to win the Nobel Prize? Answer: Tini Veltman, the one who wrote his program in CDC 6000 assembly language, which feels less visionary, but his Nobel Prize wasn't for writing code in assembly language. It was for things about the standard model of particle physics. All right, let's see. Do we have any of these? What's this? We can find some horrifying thing here. This looks like some description. Oh, this is when it was called SAM, Symbolic and Algebraic Manipulator. System functions in SAM will consist of subroutines and compiled C code, which are called by the interpreter in order to evaluate the functions when they are found in expressions, or an executable SAM code, which is treated as a special type of expression. Someone's asking if I used APL. I never actually ran a live APL, but I certainly studied its documentation. Lisp and APL were the two languages that I really thought were interesting, and where I studied their documentation. I got to know Ken Iverson, the creator of APL, years later, but I never really used it as a practical thing. All right, let's see what there is here. Let's see if this is what's that? Is that C code? Oh wow, that's very, very early. That is when it went through another name. It was called Algae, the algebraic manipulator, and that is a very early okay, that's gamma matrix traces for direct gamma matrix traces from particle physics, and that's one of the people who worked on looked a bit on SMP. Actually, he was a Lisp enthusiast, and he didn't. SMP was written in C. It's a person, I believe, a person called Don Mitchell, who went on to have a distinguished career in computer graphics. Let me see, where were we looking there? Let's see, what's this? Is the C code? Oh yeah, there it is. Okay, well, there you have it. That's some early C code for SMP. Together with, oh my gosh, how horrifying. So this must be, look, it's using realloc, which is a deadly function. And it's also using, the fact that it's using the allocator explicitly is really horrifying. In the middle of some, if FFTE of star B, so this is a derivative. This is it taking a, somehow it's taking a derivative, and somehow it's calling the allocator in the middle of the code that takes the derivative, which is truly a horrifying thing to contemplate. And that looks like a YAC grammar. That looks like some kind of, some things don't change. Okay, that looks like a little piece of C code. Let's see whether we can find any other exciting things here. Huh. Yeah, well, that was outreach in those days. We gather you have made the most advanced implementation of the Risch symbolic integration algorithm. Okay. That person, yeah, it's, I think that person eventually went into making C compilers. Okay, that looks like it's SMP documentation. Let's see what this is. Tentative design for SMP. Seems to be somebody else's copy. Okay, that's language summary. Okay, that was another bad idea for a name. I am the intelligent algebraic manipulator. Let's see what I had to say about I am. And it wasn't even a will. Okay. Dynamic GC, true. Performing dynamic garbage collection. Okay. Let's see what else we have here. I wonder what that is. Not relevant, just something about gamma matrix reduction. Let's see what that is. That's got a big Swolf banner. 1982. Following features of SMP do not agree with the manual. Sigh. Name changes. The main simplifier has been rewritten to treat recursion in a more flexible fashion. Oh, these are release notes. This is release notes from April 27th, 1982. Let's see what is polynomial resultants. Okay. That was let's see what else there is here. What is this? That seems to have been just, I mean, there's lots of stuff we haven't looked at, which is traveling around to different places. Acknowledge receipt of your contribution to the 1981 DECUS US Symposium. That was the DEC Users Group, Digital Equipment Corporation Users Group. For your information, a 2x2 slide projector and an overhead projector transparency projector will be available. I wonder if I was using by that point an LCD, a big lug it around LCD projection system that could project a terminal. I don't know whether I was yet doing live demos at that time. I think I might have been. All right, let's just see what something like this is. Computer algebra. Okay. Introduction to computer algebra. Not too exciting. Written with my friend Chris Cole. More, I was showing this earlier, but that's a Maxima output. Summer job. Somebody looking for a summer job. I'm sorry, I've decided to work for another employer this summer. Oh well. No doubt that person went on to all sorts of exciting successes. Somebody is asking, I hope you're enjoying several chocolates so you can have a lot of energy to continue the stream. I'm sorry, yes, I am nibbling away. All right, I think we should wrap this up really soon. Let's see whether there's any other final things that might be fun to look at. Let me see. I might have a yes. I'm going to look at one more thing here. Some aspects of which may be too horrifying to share, but well, okay. This is some material from it's pulled together like a decade ago. That's the press materials from the original Mathematica product announcement, including as an IBM press release, IBM, Ardent, company I mentioned earlier, Autodesk, we were working with at that time. We really should work with them again. We should send them this again and say, this said we were going to work together, but it's only been 32 years. Hey, we should make sure there's a Wolfram engine inside some of these modern products. Corporate speakers. Steve Jobs, Bill Joy of Sun Microsystems and VI fame, Larry Tesler, and others, test users. Some interesting characters, including some that I've heard from even within the last few weeks, like Dana Scott, longtime mathematical logic person. And oh, there we go, a swank picture of Mathematica running on a Next. And a show off, look at what we can do image. All right, let's see what else we have here. See whether there's some other fun things here. Early promotion for student versions. Looks like there are a lot of birthday cards I got a decade ago. That seems to be my business card from when the company was first existed. I think I've upgraded since then. Oh boy, that is a post-it with possible names for children. Okay. That's oh, yeah, okay. So there are things. It's probably a young me picture from who knows how old, 6 years old maybe? I don't know. Lots more hair at least. That's probably a little bit more recent. I think this one is even in my scrapbook. That's yeah, now those books, of course, in the background, any mathematical physicist can probably recognize some of those books, like the theory of Bessel functions. I think that's a box of staples for a stapler. These are probably things that I had in my other scrapbook, unless there are things here that are that's a thing from my sort of housemaster person when I was probably 13. What does this say? There's probably there's little to add to these school reports. Stephen is brilliant, how nice, and somewhat reluctant to put all his energies into subjects he finds less interesting. However, he has quite a while before he specializes. Yeah, hard for you to say. I think I was mostly spending my time doing physics by that point, but not. And I should expect him to respond to various something or other as he is highly ambitious. Not sure I would agree with that. He is a shrewd person, and I feel agrees well with life in a boarding school. He's quite mature for his years, and I'm impressed with the way he copes with any immature behavior on the part of his contemporaries. Boy, I could say I've been doing that for a while. Anyway, okay, let's see. All right, a few more things and then we'll wrap this. What's this? This is stock certificate of my first company. What's this? That's the IPO prospectus for what that company turned into when it finally undistinguishedly went public in the mid-90s. All right, let's see if there's anything else here, and then we will wrap up. What is that? A wager that the Z0 boson will be discovered in E plus E minus collisions between an energy of 75 and 100 GeV, and I said it would, and Jan Ambjorn said it wouldn't. Let's find out. Z0, whoops, Z0. Unit, no, particle. No, I don't want particle. I want particle instead. How nice. You know what? I bet I've never collected on this. Okay, screen capture time. And I need to send that to Jan Ambjorn with that, those two sides. What am I collecting? I'm collecting chocolate, I think. Is that what it said? Let me take a look. What did it say? It says 1 month's supply of ice cream and orange juice. Okay, still relevant, I would say. All right. Well, I should wrap it up here. Oh, that's kind of somebody to send me some birthday greetings. That's nice. All right. Well, listen, I said I would talk a little bit about the future. So I will be back in a few minutes, and we'll yak some more about the future. Thanks for joining me so far.